In April of 1935, in a small workshop on Roosevelt Avenue in Springfield, Massachusetts, two men leaned over a workbench and held a brass cartridge in their hands. Major Douglas B. Wesson, vice president of Smith Wesson and a third-generation gunmaker, had personally machined the chamber tolerances. Beside him stood Philip B. Sharpe, author, ballistician, and the most respected cartridge researcher of his generation, with over 20 years of hand-loading data accumulated at his bench in Emmitsburg, Maryland. They had spent the better part of 7 years working with Winchester engineers to perfect the powder charge. They called the cartridge the .357 Smith & Wesson Magnum. Sharpe believed they had built the most versatile cartridge in American shooting history, a round powerful enough to take white-tailed deer at 100 yards from a rifle, accurate enough to win matches from a revolver, and reliable enough to stake a man's life on. He recorded that belief in his 1937 manual, Complete Guide to Handloading, a book still on the recommended reading list at the United States Army Marksmanship Unit. 91 years later, walk into any local gun shop in America, place hard-earned money on the glass counter, ask for a .357 Magnum lever-action carbine. The clerk will point to the same 3 rifles every time: the Henry Big Boy, the Ruger-made Marlin 1894, a standard Rossi R92. The same mainstream lineup repeated across every shop, every magazine, every YouTube channel, as if no other rifles in this caliber exist on planet Earth. But they do exist. And the reason most American hunters have never heard of them is not an accident. It is a documented story of corporate marketing budgets, vanished factories, defunct importers, and engineering choices that the modern firearms industry has quietly walked away from. This is Huntforge. The buried record opens today. There is a phrase that gets repeated in gun shops, on hunting forums, and at firing ranges across the country. It's only a pistol caliber. Good for 50 yards, maybe. Anyone who repeats that phrase has never read Phil Sharpe. In his 1937 manual, Sharpe documented something the modern industry has actively suppressed. The .357 Magnum was never designed as a handgun cartridge first. It was engineered as a dual-purpose rifle and revolver round with the rifle as the primary platform. The revolver, in Sharpe's own technical notes, was the secondary use case. The physics behind that design choice are simple, and they have not changed in 90 years. When a .357 Magnum is fired from a 4-inch revolver, 2 failures occur in sequence. First, high-pressure combustion gas escapes through the cylinder gap, that small space between the front of the cylinder and the rear of the barrel-forcing cone. Engineering studies conducted at the H.P. White Laboratory in Bel Air, Maryland, under the supervision of Dr. Martin Fackler, founder of the International Wound Ballistics Association and a combat surgeon with 28 years of United States Army Medical Service, documented gas pressure losses of up to 15% through that gap alone. Second, the slow-burning powders preferred for Magnum loads, Hodgdon H110, Winchester 296, Alliant 2400, are formulated to burn over distances substantially longer than 4 inches. In a short revolver barrel, the bullet exits the muzzle while a significant percentage of the powder is still combusting. The famous Magnum fireball that photographers love is not a sign of power. It is a sign of wasted energy. Now chamber that exact same cartridge into a 16 or 18-inch carbine. The cylinder gap disappears. The closed breech of the rifle action seals the combustion chamber completely. The slow-burning powder finally has the runway it needs to achieve total combustion, building pressure progressively as the bullet travels down the bore. The result is documented and reproducible. Independent ballistic chronograph testing by the Ballistics by the Inch Research Project, which has tested over a dozen common defensive cartridges across barrel lengths from 2 inches to 18 inches, recorded standard 158-grain .357 Magnum loads exiting a 16-inch carbine at velocities between 1,750 and 1,850 feet per second. Heavy 180-grain hard-cast loads from buffalo boar exceed 1,650 feet per second from the same barrel length. Run those velocities through the kinetic energy equation, 1/2 mass times velocity squared, and a 158-grain bullet at 1,800 feet per second produces approximately 1,135 foot-pounds at the muzzle. That is not pistol caliber territory. That places the .357 Magnum carbine in the same effective performance range as the .35 Remington at moderate distances, and well above the lower-end performance of any pistol caliber alternative. Combined with the higher sectional density of a .357 diameter projectile compared to a .44 caliber bullet of similar weight, the result is straighter, deeper penetration through bone and muscle, with measurably less recoil. Idaho rancher Elmer, the gun writer who logged over 50 years of field experience, took elk, black bear, and whitetail with .357 Magnum carbines and recorded those hunts in detail in his 1955 book Six Guns by Keith. His verdict in writing, "The .357 from a carbine was ample medicine for any North American game short of grizzly." That is the foundation. The cartridge has always belonged in a rifle. The 5 carbines documented in this archive maximize what Sharpe and Wesson built 91 years ago, and the modern firearms industry has spent 2 decades steering buyers away from every one of them. In January of 2024, Smith & Wesson released the first lever-action rifle in the company's 172-year history. The model designation was deliberate. The 1854 honors the year the firm was founded by Horace Smith and Daniel Wesson in Norwich, Connecticut. The American firearms press largely missed what was actually happening with this rifle. Most modern lever-action carbines in the entry and mid-tier market, including current production from at least 3 of the major American brands selling under the $700 to $1,200 price ceiling, utilize investment cast receivers. Casting is faster and cheaper than forging. Molten steel is poured into a ceramic mold, cooled, then machined to final dimensions. The process can leave microscopic voids in the grain structure, and the crystalline alignment of the metal is essentially random. Smith & Wesson made a different choice. The 1854 receiver is machined from forged 416 stainless steel. Forging takes a solid steel billet and shapes it under tons of mechanical pressure, often at elevated temperature. The crystalline structure of the metal aligns along the lines of stress. Tensile strength can increase by 20 to 30% compared to a cast equivalent of the same steel grade. Smith & Wesson combined that forged receiver with a round-bottomed bolt that fully encloses the cartridge case head and a lateral locking lug that engages a recess machined into the receiver wall. A 2-piece firing pin functions only when the lug is fully seated. If the action is even slightly out of battery, the firing pin cannot transfer energy to the primer. For a hunter running heavy hard-cast hunting loads at the upper end of the SAMI pressure specification, 35,000 psi for .357 Magnum, that mechanical interlock is a margin of safety that cast receiver lever guns simply cannot match at the same level. The barrel twist rate on the production 1854 is 1 turn in 18.75 inches. Most traditional .357 lever guns from the major American manufacturers run twist rates between 1 in 16 and 1 in 20 inches. The 1/1875 of the 1854 is a deliberate engineering compromise, fast enough to stabilize 180-grain hard-cast hunting bullets at carbine velocities, slow enough not to over-rotate lighter 125-grain practice ammunition. For a hunter selecting one rifle to handle bear country defensive loads and weekend range work, that intermediate twist is more useful than the marketing department twist rates competitors, quote, without context. Add a flat-face trigger breaking near 5 pounds with negligible over-travel, a factory-threaded muzzle in 5.8x24 for sound suppression, and an XS Sights ghost ring system included from the factory, and the 1854 is positioned not as a nostalgic reproduction, but as a working rifle for the next generation. It weighs 6.8 pounds, a half-pound heavier than its closest direct competitors. That weight is not a flaw. It is felt recoil reduction engineered into the design. The reason most gun shops still steer customers toward the Henry Big Boy or the Ruger Marlin 1894 instead is not engineering. It is shelf space, distributor relationships, and marketing spend. Henry Repeating Arms, headquartered in Bayonne, New Jersey, allocates an estimated several $1 million annually to national television advertising alone. Smith & Wesson, despite its century and three-quarters of history, is the new entrant in a category dominated by 90 years of brand inertia. Approximately 115 miles northwest of the Negev Desert, in the industrial complex at Ramat HaSharon, Israel Military Industries, the same state-owned defense conglomerate that produced the Galil battle rifle and the Uzi submachine gun, manufactured a carbine in the late 1980s and early 1990s that almost no American hunter has ever handled. It was called the Timber Wolf. It was designed by Evan Wilden, a firearms engineer with over 2 decades of design experience, formerly an executive at the American importer Action Arms of Philadelphia, Pennsylvania. It is not, technically, a lever-action rifle. The Timber Wolf is a pump-action carbine chambered in .357 Magnum with a tubular magazine holding 10 rounds. The decision to include a pump action in an investigation of overlooked lever guns is deliberate because the Timber Wolf solves the single greatest biomechanical limitation of the traditional lever-action design. When a shooter operates a lever gun, the firing hand must release the pistol grip, drop down to the lever, swing a heavy steel arm through approximately 30 degrees of arc, and return to the grip. Unless that shooter has trained for thousands of hours in cowboy action competition under the discipline of figures like the late Bob Munden, the Grand Master who held 18 world records and accumulated over 50 years of competitive shooting experience before his death in 2012, that motion disrupts the cheek weld, the sight picture, and the firing hand position simultaneously. The Timber Wolf eliminates the problem entirely. The trigger hand never moves from the grip. The cheek stays welded to the stock. The support hand cycles the slide horizontally along the same axis as the recoil impulse. The mechanical forces of operation are aligned with the natural motion of the shoulder absorbing the shot. The result, demonstrated in side-by-side comparisons at training events, including those documented at Gunsight Academy in Paulden, Arizona, is a cycling speed that exceeds the fastest competition lever gun shooters by measurable margins. The Timber Wolf was built to Israel Military Industries quality control standards, which during the late 1980s exceeded the inspection protocols of most American commercial manufacturers, driven by IMI's primary role as a military contractor to the Israel Defense Forces. The receiver included a takedown mechanism allowing the buttstock to be removed for compact transport. Field reports from collectors place the disassembled package length at under 25 inches, small enough to fit inside a standard hiking ruck. Because the action is a pump rather than a lever, sensitivity to cartridge overall length is dramatically reduced. The Timber Wolf feeds .38 special wadcutter target loads and full-pressure .357 Magnum hunting loads with equal reliability, a flexibility that gives lever gun designers headaches and frequently produces feed failures in less engineered tubular feed designs. Production reportedly ended in the mid-1990s after Action Arms ceased operations as an importer. Total imports into the United States that's, while never officially confirmed by IMI, are estimated by collectors at fewer than several thousand units across the entire production run. A clean used example today sells for 2 to 3 times its original retail price. The reason the Timber Wolf is not on the shelf at the local gun shop is not because it failed in the field. It is because the company that imported it went out of business. The product was orphaned. The pump-action carbine that outcycles every modern lever gun was locked into the used market by an accident of corporate history. and the major American brands have not replicated the design in the 30 years since. The Winchester 1892 action was designed by John Moses Browning, the most prolific firearms designer in American history, with over 128 patents and 47 years of design work behind him at the time of his death in Liège, Belgium, in 1926. The 1892 used twin vertical locking lugs that rose from the receiver to engage the bolt, an action so strong, so smooth, and so mechanically efficient that no competing pistol-caliber lever gun has ever truly surpassed it in 134 years. Italian manufacturer Chiappa Firearms, headquartered in Brescia, took Browning's century-and-a-third-old mechanical design and re-engineered it with 21st-century materials science. The Chiappa 1892 Alaskan takedown uses an interrupted thread takedown system at the junction of the barrel and receiver. In under 10 seconds, with no tools, the rifle separates into two assemblies that fit inside a standard hiking backpack. The engineering detail that matters, the detail most takedown rifles get wrong, is sight placement. Many takedown designs mount the rear sight on the receiver and the front sight on the barrel. Every reassembly introduces microscopic variance in the lockup, which translates directly to point-of-impact shifts at 100 yards and beyond. Chiappa mounted both the Skinner Ghost Ring rear sight and the fiber-optic front sight on the barrel assembly. The mechanical relationship between the two sights never changes. Zero is permanent across infinite takedown cycles. The finish is more important than most buyers realize. The Alaskan is not stainless steel. It is carbon steel coated in matte hard chrome. Hard chrome plating produces a surface hardness on the Rockwell C scale exceeding 70, significantly harder than 416 stainless steel. Beyond pure hardness, hard chrome provides a self-lubricating, low-friction surface that allows the action to cycle reliably in conditions. Saltwater spray on a coastal Alaskan hunt, freezing rain in the high country, alkaline desert mud that would seize a stainless or blued action within hours. The walnut buttstock is not raw walnut. It is sealed walnut wrapped in a high-friction soft rubber overmold. Wood swells in humidity and contracts in cold. The overmold isolates the wood from environmental moisture and provides a no-slip grip surface against wet hands and wet hunting clothing. Total weight is 5.9 pounds, light enough for a multi-day backcountry hunt, heavy enough to stabilize the rifle under field shooting conditions. The Chiappa Alaskan is not on the shelf at the major American chains for the same reason as the Timber Wolf. It is imported. Distribution is limited. Marketing budget, compared to Henry Repeating Arms or to Sturm Ruger and Company, the corporate parent of Marlin since 2020, is essentially nothing. The mainstream firearms press allocates editorial coverage in proportion to advertising revenue. A small Italian importer cannot compete with the multi-million-dollar national television campaigns of the major American brands. The shooter who finds and buys an Alaskan has made a choice based on engineering. The shooter who buys the heavily advertised alternative on the same shelf has, in many cases, made a choice based primarily on the marketing budget that put that rifle in front of him. Brazilian manufacturer Rossi has been producing copies of the 1892 Winchester action under license for over 40 years. To the uninformed buyer, every Rossi looks the same. The reality is far more complicated, and the difference between a good Rossi and a frustrating one comes down entirely to production era. There are three distinct generations. The interarms era ran from approximately the early 1980s into the late 1990s, when Rossis were imported into the United States by Interarms of Alexandria, Virginia. The action design was clean. The receiver had no externally mounted manual safety. The lever stroke was light and crisp. Many of these rifles, machined in Brazil and inspected by Interarms staff before retail distribution, are still cycling smoothly today after 40 years of working use. The LSI Puma era ran from the late 1990s into approximately 2010, when Legacy Sports International of Reno, Nevada, took over importation and the rifles were marketed under the Puma sub-brand. Quality remained generally consistent with the interarms era, though minor cost reduction measures began to appear in stock checkering and metal polishing. The Brastec Taurus era runs from approximately 2010 to the present, when Rossi was fully absorbed into the Forgis Taurus Brastec corporate structure, following a series of consolidations in the Brazilian firearms industry. This is where the trouble started. Modern production rifles include a manual crossbolt safety mounted on top of the bolt, a feature added under American product liability legal pressure rather than for any mechanical or functional reason. Internal springs were specified heavier to guarantee primer ignition under worst-case ammunition tolerance, which produces a stiff, gritty lever stroke that experienced shooters describe as fighting the gun. The Browning lever rifle, introduced in 1969 and refined continuously across 5 decades, is the most mechanically sophisticated lever-action rifle in current production anywhere in the world. It is also the rifle that most lever gun purists pretend does not exist. The reason becomes clear once the action is opened. Every traditional lever-action rifle, the 1892, the 1894, the Henry, the Marlin, uses a tubular magazine running parallel to the barrel and a rear-locking toggle or sliding bolt mechanism. The BLR throws all of that engineering history out the window. It uses a rack and pinion gear system connecting the lever to a rotating multi-lug bolt head. The bolt locks directly into a barrel extension, the same locking principle used in the AR-15 platform and in modern action precision rifles built by companies like Sako and Tikka. Because the locking surfaces engage the barrel directly rather than the receiver, the BLR is rated for cartridges generating chamber pressures in the 60,000 psi range, well above what any traditional lever gun action can safely contain. The second engineering departure is the magazine. The BLR uses a detachable box magazine, not a tubular magazine. This matters because of bullet shape. In a traditional tubular magazine, cartridges sit nose to primer in a single line. If a shoots loads pointed Spitzer bullets, the aerodynamic profile preferred for accurate long-range performance. The sharp tip of one bullet rests directly against the primer of the cartridge in front. Recoil can drive that point into the primer hard enough to ignite the cartridge inside the magazine. Documented incidents of tubular magazine detonations have produced injuries to shooters as recently as the past decade, which is why every traditional lever gun manufacturer prints the same flat nose only warning in their owner's manuals. The result is that traditional lever guns are functionally limited to flat nose or round nose bullets, both of which carry ballistic coefficients below 0.250. At 300 yards, a flat nose bullet has shed enough velocity to drop dramatically and to hit with substantially reduced energy compared to its muzzle performance. The BLR's detachable box magazine isolates each cartridge entirely. Spitzer bullets, with ballistic coefficients up to 0.450 in .35 caliber, feed without risk. Browning does not factory chamber the BLR in .357 Magnum, but the BLR is offered in .358 Winchester, and competent custom gunsmiths regularly chamber the platform for hot-loaded .35 caliber Wildcat cartridges that approach the performance of factory .35 Wellen ammunition. For the shooter who wants the rapid-fire potential of a lever action paired with the long-range precision of a bolt action, the BLR is the only rifle on the market that delivers both in a single package. It is also the rifle that the lever gun traditionalist community has spent 55 years quietly trying to ignore. Because admitting that John Browning's grandsons at the Browning Company solved the lever action's engineering limits in 1969 means admitting that the romantic 1894 design has been technically obsolete for over half a century. In April of 1935, Phil Sharpe and Major Douglas Wesson stood in a workshop in Springfield, Massachusetts, and held a brass cartridge in their hands. They believed they had built something that would last for generations of American hunters. They were correct. The cartridge has lasted. The rifles built by craftsmen who understood what the .357 Magnum was actually designed to do. Those rifles have not all survived the consolidation of the modern firearms market. The Smith Wesson 1854, the IWI Timber Wolf, the Chiappa 1892 Alaskan Takedown, the pre-safety Rossi R92, the Browning BLR. 5 carbines that, for reasons of marketing budgets, defunct importers, corporate consolidation, and lawyer-mandated design compromises, have been pushed into the dark corners of the American firearms market while inferior alternatives sit at eye level under the glass. There is a hard truth that gets lost in modern firearms content. Most rifles sold in America today are sold the same way breakfast cereal is sold, through shelf placement, brand recognition, and television advertising. Engineering merit is a distant secondary factor, and sometimes not a factor at all. Huntforge has documented the proof in this archive, but every researcher carries a quiet doubt. Because the marketing departments of the major brands have resources that no independent voice can match, and the entire industry is structured to bury work like this beneath the noise of the next product launch. That doubt is the reason this work matters. The American hunting tradition was not built by marketing departments. It was built by the Phil Sharpes and the John Brownings, by the Idaho ranchers like Elmer Keith and the backcountry guides whose names never made it into a magazine, by the working men who chose tools based on what those tools actually did in the field. To choose a .357 lever gun based on engineering rather than advertising is not nostalgia. It is the act of standing inside a tradition that the industry would prefer to forget. If that tradition matters, if the difference between a forged 416 receiver and a cast equivalent matters, if a 118.75 twist rate that genuinely stabilizes 180-grain hard cast hunting loads matters, if the right to buy the best tool rather than the best marketed tool matters, then this channel is the place to stand. Subscribe, not as a courtesy, not as a social gesture, as a declaration of where a hunter chooses to stand inside this industry. The next investigation goes deeper. The .4 Special, a cartridge older than the .44 Magnum, more accurate than the .44 Magnum, beloved by Elmer Keith himself across 40 years of writing, and quietly buried by the same Smith & Wessons when the Magnum eclipsed it in 1955. The lever guns chambered for it, the reasons it never died despite the industry's best efforts to retire it. That archive opens next. Until then, forge the truth. Shoot straight. See you on Huntforge.